Hi everyone, it's my honor to give this video presentation to introduce our project. The title of our project is Grading of Tomatoes using Color Detection Image Processing by using MATLAB. And the theme is based on the vegetable grading. So my name is Ming, metric number 187862, and my members Tiong, metric number 187096. The introduction of our project is the tomato has a high demand in the world. The global tomato market revenue amounted to the 190.4 billion in 2018, and it has a rising trend on the demand of the tomato. So the grading of tomato in this project will refer to the color of the tomato and using the color detection algorithm image processing technique, and if you justify tomato whether it is in ripe, unripe, and rotten condition. The grading in the tomato on the degree of ripeness will put the consumer easier to pick the tomato or make the transport easier and make the easier packaging, and it will save more time to process it. The objective of our project is we need to determine the ripeness of tomato whether it is in ripe, unripe, or rotten conditions. And we will use the color detection image processing technique to detect the color of the tomato in the image. And we will display a message to tell the user whether the tomato is in the ripe, unripe, or rotten conditions. So basically this is the image of the grading of the tomato. If the above is showing the tomato is in the green color, which indicate it is an unripe tomato. So there are three stages, which is a mature green, breaker stage, and turning stage. And the tomato in red color indicate the tomato is in the ripe condition. It has a pink condition, ripe condition, and full ripe condition. So this is the tomato condition explanation. The mature green indicate that it is suitable for sending to distant market. Breaker stage means that there is less than 10% of the area turns pink or red color, and the turning stage indicate that there is around 10 to 30% area turn pink or red color. So the pink stage indicate that the tomato is not fully ripe, but there are around 30 to 60% of the surface shows pink or red color and suitable for the local market. The ripe condition means that the major portion of the tomato turns into ripe, and around 60 to 90% of the surface of the tomato is pink and red. And the full ripe stage of the tomato means that there are more than 90% of the surface on the tomato is in red color. For the rotten tomato grading, the tomato will show the brown color on the surface. And when the brown color is detected on the tomato, it can be graded as the rotten tomato. There are two images to indicate that the condition of the tomato is in rotten. So the concept to grade the tomato using the color detection image processing, right? For the unripe tomato, it means that it indicates that less than the 30% of the color detected in the tomato image, it can be justified as unripe tomato. If there are more than 30% of the red color detected in the tomato image, it can be referred the tomato is in the ripe conditions. If there are more than 5 of the brown color detected in the tomato image, this is to avoid the false detection due to the color of the tomato stem. So it can be referred as the tomato is in rotten condition. So for the methodology, firstly, I will tell the procedure part of our project. So first thing first, we will download the different tomato image from the internet, and it will include the ripe tomato, unripe tomato, and also the rotten tomato. Around there are 8 ripe tomato images, 8 unripe tomato images, and also 8 rotten tomato images we will be testing under our project. Each of the tomato images contain only one tomato with different level of ripeness. The images will be loaded and processed by using MATLAB. The color detection image processing technique will be used to detect the color of the tomato in the image, and each of the tomato images will be processed and show its condition, whether the tomato is unripe, ripe, or rotten. So next I will pass to my members Tiong Seng to introduce the flowchart of the project and so on. Thank you.
This is the flow chart. Start, we will upload in tomato images, and then the system will automatically remove the white background and then extract out the color bands into 3 separate 2D arrays, which are red, green, and blue, and compute and plot the red, green, and blue histogram. After that, find all the gray level with count more than 0 in red, green, and blue histogram. From all the non-zero histogram count, we will find average gray level for each histogram, and we will compare the average gray level of red, green, blue image with benchmark and display the result. For the benchmark, we have 4 images to do as our benchmark. This 4 is rotten, ripe, and unripe. You can see here got mean non-zero red, mean non-zero green, and mean non-zero blue. It's red, green, and blue. So you can see all the value is different. So we use those value to do the classification in our MATLAB software. And you can see here got 3 folder and 1 file for the code file. Okay, so we open the code. You can see here this is the code that used to do detection for tomato. Okay, and firstly we will go to choose fresh tomato, and you can see here 1 2 3 4 5 6 7 8 fresh tomato, and we will choose fresh 2, fresh 3, and fresh 5. Copy it, and then we will paste to here for detection. Okay, and to do the fresh tomato, this is the fresh 2 I will going to do first, and go to change here, because here is the code for us to upload the image. Okay, and the fresh tomato, this here is fresh 2. We run it, and you can see we upload it and we detect it as ripe tomato. Okay, you can see this is an image become black background. This is a histogram, red, green, and blue. And from here, I have to show you again. This is a ripe tomato, and its original image is this one. Yeah, you can see this one is belong to this original. We will use the white background as the basic to do detection. Okay, and then next one is the fresh 3. Run your so yeah, successfully detect the right tomato. This one is belong to this. Okay, and next one we will going to do upload fresh 5. Run it again. Yeah, right tomato. This one is belong to here. Okay, to prove it, we use the original, and these 3 tomato successfully detect as ripe tomato. Now we choose unripe tomato From here you can see got 1, 2, 3, 8. Got 8 tomato. So we will choose this one, and this one to do our detection. Paste here again, and then we will open the code. Now we have to change here a bit for us to upload the unripe tomato. Okay, this is the line that used to upload the unripe tomato. The unripe tomato 3. Run it. Yeah, unripe tomato. From here, this one is belong to this one. Okay, and we will do the next one. Unripe 5. Yeah, run it also. Yeah, it detect as unripe tomato. This is belong to this one. Okay, and we do the another one, which is unripe 8. We run it and we get unripe tomato. Detection is successfully. This is belong to this one. Okay, and then now we will choose rotten tomato. Here got 7 rotten tomato, so we will choose this one, and this one to do our experiment. Okay, we copy it, and then we will paste here again and open the code. Now here we will adjust a bit to upload the rotten tomato. Okay, here become rotten 1. Run it. Yeah, rotten tomato detected. You can see here I want to profit that our original image, this one is belong to this original one. Okay, this one is the rotten tomato. Now we do rotten 3. We upload another one. Yeah, rotten tomato. It can classify it as rotten tomato. This one is belong to this one. Okay, for the last one image we want to use rotten 5. Let's see. Yeah, rotten tomato is detected. This one is belong to this one. Okay, before that I want to conclude that we have already do 1, 2, 3, 4, 5, 6, 7, 8, 9 sample we used to do detection, and we successfully detect all as fresh, rotten and unripe.
In conclusion, vegetable grading is important for sorting the vegetable in the processing stage. The purpose of the sorting vegetable is according to the parameters such as diameter, length, shapes, and color. But in our project, the parameter we use in grading the tomatoes is using the color parameters. This project could be further improvised and can be implemented in machine and sorting out the tomato for the fruit processing and also the fruit transport. The tomato is generally carried through the high precision system, and it can be packed, and this can be used for the packaging stage. Overall, our objectives are achieved, and we use the MATLAB software. We can determine the tomato is whether in unripe, rip or rotten conditions. Based on the color detection image processing technique, we hope that this project could be improvised in future. Thank you.